Good morning everyone. So this is the video lesson 16, types of materials or mediums for the electromagnetic wave propagation. Okay, so in previous video lessons we discussed the propagation mechanism of electromagnetic wave in free space. Okay, so we discussed many important parameters of electromagnetic wave in free space like speed, impedance, energy density, Poynting vector, and its transverse nature. And we do a lot of things there. Okay, so now here one important question arises. Does the electromagnetic wave travel only in the free space? The answer is no. The electromagnetic wave can travel in the wide variety of materials like gas, like liquids, and like solids. Because you know very well that the gamma rays, the rays emitting from the radioactive elements, can penetrate the aluminum sheet or like some other metallic sheets. Okay, so now how can we classify the medium as per the propagation characteristics or the propagation properties of the electromagnetic wave? So now let's discuss this issue in this video lesson. Okay, so depending upon the propagation properties, okay, what are the propagation properties? Propagation properties is the speed, is the refractive index, is the propagation property, is the impedance, energy dissipation, like that things. Okay, so depending upon the propagation properties of the electromagnetic wave, materials can be classified as. So this is the classification. There are mainly three types of the medium. One is the conductors, the dielectrics or insulators, and the last is the quasi-conductors. Okay, so these names are too much similar with the classification of the materials on the behalf of the electric current conductivity. However, the meaning of this classification in the reference of electromagnetic field theory is quite different that classification of the materials. Okay, so now in fact in electromagnetic field theory, the dividing line between the conductors and dielectrics is not very sharp. Okay, because it depends on the frequency. So in electromagnetic field theory, which material is conductor, which material is dielectric, which material is quasi-conductor is not well defined. It totally depends on the frequency. Okay, so one material may be conductor and the same material may be dielectric at different frequency. Okay, so a particular material can be conductor or maybe dielectric for the different frequencies of the electromagnetic wave. Basically, mu, that means permeability, epsilon means permittivity, sigma means conductivity, and omega means angular frequency or simply frequency are the deciding parameters for the type of the medium. Okay, so let's see one very interesting example of the fresh water. Okay, so fresh water is the good conductor at the frequency that are less than 10 to power 3 hertz. And now fresh water may be dielectric if the frequency of the electromagnetic wave which are propagating through the fresh water are greater than 10 to power 7 hertz. So the medium is same, but it may be good conductor, but it may be dielectric depending on the frequency. So now question is that how can we decide a particular medium is conductor or dielectric or quasi conductor on the behalf of the frequency? Okay, so now let's see another slide. So for this, let's define the ratio. Let's define one important ratio. This is the mod Jc over Jd. Jc is the conduction current density, sigma E JD is the displacement current density. Okay, this term arises in the Maxwell fourth equation. JD is equal to del D over del T. This ratio is known as the loss tangent, or dissipation factor is equal to tan delta. Here delta is known as the loss tangent, angle of loss tangent. Okay, so this ratio represents the loss of power or dissipation of the power due to the propagation of electromagnetic wave in dielectric compared with the conducting medium. Okay, so now we can solve this ratio. Okay, Jc is equal to sigma E, Jd is equal to del D over del T, and whenever we solve this ratio and take the modulus, okay, the value is sigma upon omega epsilon. Okay, so here we may assume that tan delta is equal to Jc over Jd is equal to sigma divided by omega epsilon is equal to 1 is the benchmark for the conductors and the dielectrics. Okay, so this is the fine line between conductor and dielectrics. So now let's discuss the following cases. Case first, when tan delta is equal to Jc over Jd is equal to sigma upon omega epsilon is very greater than 1. Okay, so very greater than 1. That means conduction current is very greater than the displacement current. Then the medium is known as the good conductor. Okay, so when the conduction current is very high, the medium is known as the good conductor. Case 2, when this ratio is very less than, the medium is known as the dielectric. Okay, the medium is known as the dielectric or insulator. And if this ratio is approximately equal to 0, the medium is known as the ideal or lossless dielectric. Okay, and if the ratio is not equal to 0 but slightly greater than 0, the medium is known as the loose dielectric or the imperfect dielectric or the partial conductor. Okay, so this is the classification. Now let's see the last case, when tan delta is equal to 1. In this situation, the medium is known as the quasi-conductor, and these mediums are totally different as the semiconductors. Okay, such type of the classification you must learn in the conductivity chapter. So semiconductor and quasi-conductor are totally different. Okay, so a quasi-conductor is made of a substance which under particular condition behaves either purely as conductor or purely as an insulator. Okay, so such medium are known as the quasi-conductor. So you must see the bike and the spark plug of the bike of the motorcycles. Okay, so the porcelain of a spark plug, when it is dirty or it has some moisture, and in this situation the spark plug leak the spark to the atmosphere. You all know, acting as the perfect conductor, and there is a starting problem in the bike and hence cannot ignite the fuel. Okay, in the otherwise scenario it acts as a perfect insulator and induces spark at the right place and the right moment to ignite the fuel. So such type of materials are known as the quasi-conductor. Thank you.